Sam Cooke, and I'm a senior chemical engineering major at the University of Pittsburgh. And this summer I did a REU down at Clemson University where I investigated the cell culture of Chinese hamster ovary cells, which is a really specific cell line that's being used for gene therapy applications. So what my project was about was modeling bioreactors containing these cell cultures and how to optimize these bioreactors for most efficient growth. Because these cells are mammalian cells and it's really expensive and time-consuming to work with these. So we really have to model them as best as we can to optimize this process. So what I did in this project was I used MATLAB's neural network toolbox to figure out which parameters were most important for modeling these cells. So this here is what kind of a neural network looks like. So they can be used a lot for data analysis because they can take in huge amounts of data and they can narrow it down to what's most important for modeling these systems. So what I did was I took these data sets, which included 12 online variables such as pH and temperature were being collected every 12 seconds. And so it just resulted in a huge amount of data. So what we did was we put it into these neural networks and we had the neural network figure out how to model these bioreactors most effectively. So I also used principal component analysis, which squashes down the amount of variables used in analysis of these systems. And what I found was that the time, the dissolved oxygen levels, and the off-gas carbon dioxide levels in these bioreactors were most effective at modeling how these cells were doing. So then what I did was I built this model using E. coli sets of data because E. coli is much cheaper and quicker to work with than Chinese hamster ovary cells. And so I could run a new experiment and test how well this model is at predicting new data sets. So then what I did is I trained it with existing data sets of E. coli previous runs. And I found that after training this neural network with 6 or 7 runs, it would drop down to less than 1% mean percent error. So that kind of validates that this neural network system is good at modeling cell cultures overall. So the next step in this research would be to connect this bioreactor system with this neural network. And in turn, the neural network could then modify these bioreactor parameters in real time. So they would be kind of a smart bioreactor which could grow these cells most effectively.
Thank you.
Thank you.